Every vehicle relies on a combination of essential parts to create a functional, efficient, and safe car. Let's take a closer look at the 10 key car components and how they all work together. The engine is what powers the vehicle by converting chemical energy and fuel into mechanical energy. Most modern cars rely on internal combustion engines, ICE. In an ICE, a mixture of air and fuel, typically gasoline or diesel, is burned within the cylinders, where the combustion process takes place. This begins with the fuel-air mixture being drawn into the combustion chamber during the intake stroke, then compressed during the compression stroke. A spark plug in gasoline engines ignites the compressed mixture, causing a small explosion. This explosion generates high-pressure gases that force the pistons downward during the power stroke, producing mechanical energy. The piston's up and down motion is transferred to the crankshaft, which converts into rotational motion that powers the car's wheel. Finally, during exhaust stroke, the spent gases are expelled from the chamber, completing the four-stroke cycle. Next, we move to the transmission, a critical component that bridges the engine and the wheels. Its main function is to ensure that the power generated by the engine is delivered efficiently to the wheels, adapting to varying speeds and driving conditions. Transmission adjusts the engine's output to match the vehicle's speed and load. For instance, when starting the car or climbing a hill, it increases torque to overcome resistance. On the other hand, when cruising on a highway, it reduces torque to improve fuel efficiency. There are different types of transmission. Manual transmissions require the driver to use a clutch and a gear stick to shift gears. Each gear has a specific ratio, with lower gears providing better acceleration and higher gears optimizing cruising efficiency. Automatic transmission handles gear changes automatically using a torque converter, which adjusts power delivery through fluid pressure. The car's battery is a rechargeable unit that stores electrical energy, playing a vital role in the vehicle's operation. It provides the initial burst of power needed to start the engine by powering the starter motor, which turns the crankshaft to get the engine running. Once the engine is running, the alternator takes over, recharging the battery and supplying electrical energy to other systems such as lights, air conditioning, and climate control. The battery also acts as a buffer, managing electrical surges and offering surge power when the engine is idling and during high power demands. The alternator is an essential component of the car's electrical system, functioning as a generator to produce electricity while the engine is running. It converts mechanical energy from the spinning engine belt into electrical energy through electromagnetic induction. The alternator produces alternating current, AC, which is then converted to direct current, DC, by a rectifier, making it usable for the car's electrical components. This electricity powers systems like lights, sensors, and the car screen, while also recharging the battery to ensure it remains steady for the next engine start. A voltage regulator maintains a steady voltage, preventing faultifications that could damage the car's electronics. The fuel system is responsible for delivering fuel from the tank to the engine precisely and efficiently to ensure optimal performance. It begins with the fuel tank, which stores gasoline or diesel. Fuel pump draws from the fuel tank and pushes it through the fuel lines to the fuel filter, which removes contaminants to protect the engine. In modern vehicles, fuel injectors atomize the fuel, spraying a fine mist directly into the engine's combustion chamber. This atomized fuel mixes with the air and is ignited for combustion. The amount and timing of fuel delivery are controlled by the engine control unit ECU. The cooling system is essential for maintaining the engine at the proper temperature and preventing overheating, which could otherwise cause severe damage. As the engine runs, it generates substantial heat, which must be managed to protect the vital components. The system circulates coolant, a mixture of water and antifreeze, to the engine's cooling channels, where it absorbs heat from the engine block and cylinder head. The water pump plays a key role in circulating the coolant, which then flows into the radiator. In the radiator, the coolant is cooled by the airflow, reducing its temperature before returning to the engine to continue the cycle. A thermostat regulates the flow of coolant based on the engine's temperature, ensuring that the engine remains within the optimal range. The exhaust system plays a crucial role in managing and eliminating harmful gases produced during combustion, ensuring that the vehicle operates cleanly and quietly. It begins with the exhaust manifold, which collects gases from the engine cylinders and channels them into a single pipe. From there, the gases flow into a catalytic converter where harmful compounds such as carbon monoxide, nitrogen oxides, and unburned hydrocarbons are converted into less toxic substances like carbon dioxide and water through chemical reactions. Afterward, the gases pass through the muffler, which reduces engine noise by damping sound waves produced during exhaust flow. Finally, the gas exits through the tailpipe. The braking system is vital for controlling the car's speed and ensuring safety by converting kinetic energy into heat energy through friction. When the driver presses the brake paddle, hydraulic fluid is pushed through the brake lines to activate the brake calipers. In disc brakes, the calipers apply pressure to the brake pads which clamp onto the rotors, creating friction to slow down the wheels. Modern cars often feature anti-lock braking system, ABS, which prevent the wheels from locking up during hard braking. This feature helps maintain steering control, preventing skidding, and allow the driver to maneuver while braking. The braking system is crucial for safety as it enables the driver to slow down or stop the car efficiently. The suspension system plays a key role in ensuring a smooth and stable ride by absorbing road shocks and keeping the tires in contact with the surface. It consists of springs, shock absorbers, and struts. When the car encounters a bump, the spring compress to absorb the impact, while the shock absorbers dampen the rebound, preventing excess bouncing. The steering system. When the driver turns the steering wheel, the motion is transmitted to a steering column, to a system of gears and linkages. In many cars, this includes the rack and pinion gear set, which converts rotational motion into lateral movement, turning the wheels and changing the car's direction. Understanding how the system works helps you appreciate the engineering behind your vehicle. Thanks for watching, and I hope you learned something from the video.